I'm Mr. Craig, and Mr. Nelson's back there. Saying hi, Mr. Nelson. We're learning about explicit formulas from patterns. We've been doing explicit formulas. Remember arithmetic and geometric? But now we're going to do it with patterns. See, what do you mean, Mr. Craig? I'm like, oh, guess what? This is what I mean. If I look here, I can see that there is a pattern, right? There's 2, there's 4, and there's 6, and there's 8. There's obviously a pattern. So, just like with sequences, patterns we always assume, unless we're told otherwise, that this first one is term 1. It's the first term because it's the first one I see. This is the second term. This is the third term. This is the fourth term. So if I continue seeing this sequence and I want to know what the 10th term, I could predict what that pattern would be based on what term I have. So this is the first term. And basically all I'm doing is I can either count them and put that, or I can just put the number above it. And then all of a sudden I've taken, oops, that's not an 8. I've taken this pattern and actually turned it into a sequence. So really patterns or sequences, we just haven't written the number down yet. So it's 2, 4, 6, 8. Now, if I want to write the explicit formula, I just have to start off with the first term. What is my first term? Well, my first term is, remember Mr. Nelson said just put the A over the top of these. You can see what term it is. Oh, the first term is 2. And then what's happening each time? Well, I see that it's getting bigger, so it's going up. It's probably going to be positive, but how much is it going up by? So it's going up by 2. Well, look at that. It's doing that to each one, so I can see that's a repeat. That would make this a difference. Equals 2. I don't have to write plus because it's not, we just assume that it's positive. And if it's a difference, it is arithmetic. And arithmetic is a sub 1 equals, a sub n, you try to catch me there, equals a sub 1 plus the difference times n minus 1. So to write the explicit formula, all I'm going to do is I'm going to add the first term, which we said was 2, plus the difference, which we said was another 2, times n minus 1. Woo! 2 plus 2 times n minus 1. All right, let's get up here.
Alright,
get your pen.
So, try this one out.
Alright, so squares.
This is the same thing. We have our first term, our second term, our third term, and our fourth term. And now we just have to figure out how do we go from one to the other, right? Well, count them first. Let's see how many we got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of them. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 of them. So if it's arithmetic, we're going down by 3, but we got to keep going to make sure here. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4. So what's happening each time?
It's getting smaller.
Smaller. So let's see. We need 2 things here.
You're killing me, Smalls.
We always need the first term, and the first term is 13.
In this case, 13.
And then we either need a common difference or a common ratio for the explicit formula. And we are subtracting each time, and we are subtracting 3. So our common difference, because we're subtracting, remember a common ratio is always what you multiply by, and a common difference is always what you add or subtract by. So we have a common difference here, and that common difference is a negative 3. Don't forget that minus sign. The formula is a sub n equals a sub 1 plus the common difference times n minus 1, and you replace these pieces of information here. Starting off with your first term. So we got a sub n equals your first term, which is 13, plus your common difference, but my common difference is negative, so I'm going to say minus 3 here, and then times n minus 1. And now I can go find wherever my pattern might be later on in the sequence.
So you're saying for a pattern, all I have to do is count the number of things and turn it into a sequence?
Yep.
Man, that's difficult.
I'm Miss Craig.
All right, and there you have it.
Oh, I thought.
Hospital! I don't know. What's going on here? Well, it doesn't matter. This is supposed to be bacteria. If you were in class live, we talked about how bacteria multiplies every like 30 minutes, doubles. It's nasty. And you don't actually, when you wash your hands, you don't end up with no bacteria. You end up like, instead of thousands of them, you end up with like a couple hundred. So you always have bacteria. So this is another, again, I couldn't show it, but you can see, I don't know if you can see in the video, but there are little bacteria, and this is showing there's 16 bacteria, 32, 64. And remember, we assume that this is the first term, this is the second term, this is the third term, because this is the order that we could use this to figure out what we would have going out to eternity. So we start off with writing down what our first term is. Our first term is 16, because that's what we started with. Next, we have to check out what's going on here. It's definitely getting bigger, so it's going up. And the first thing I'll check is to see if it's addition, because addition is always a simpler one. 16 plus 16 is 32. But 32 plus 16 is not 64.
It's 48.
It's 48. So that doesn't work. So it cannot be addition, so we know it's not a difference. So the next thing to check is a ratio. And a ratio means we're multiplying. And since we're getting bigger, it's going to be multiplying by a whole number or a whole number plus some part. Just something bigger than 1. So 16 times what makes 32? 2 multiplied by 2. 16 times 2 is 32. Let's see if that continues out. Is 32 times 2 64? The answer is yes. So then I have a ratio, and it's 2. And if I have a ratio, do I have arithmetic or geometric?
Geometric.
And the geometric formula is a sub n equals a sub 1 times r to the n minus 1. And so now I just substitute those values in. A sub n equals the first term, which is 16, times 2 to the n minus 1. And sometimes students put these in parentheses so they know that that's how it goes in the calculator. And from here, I could find, if I wanted to find the 10th term, I would just place n with the term I'm looking for. Awesome. Mr. Nelson, break it down.
My turn. Bunnies!
Oh, I hear they multiply.
They multiply. Do these ones multiply? I don't know. Let's find out. All I can see is here is my first term, which I'll find right here. I'm going to come down here. I'll just count for 1, 2, 3. We have 3 here. We got, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Woo. And then we got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my first term is right here. That's my first term. My first term is 3. And then we're doing what each time? We actually are not multiplying like rabbits do, right? We got 3 to 8. Let's see here. I don't know what
plus
3
5.
times what? It doesn't work. So let's try plus 5. That works. Let's see if plus 5 works. Again, 8 plus 5, that's 13. So we do have an addition problem here, which means we have an arithmetic problem. We have our first term is 3, and my common difference then is
Plus 5.
Plus 5. We're just going to write positive 5, right? So that's the 2 pieces of information that I need to substitute into my arithmetic formula, which is a sub n equals a sub 1 plus common difference times n minus 1. And just substitute the first term and the common difference, and you can be done with it. So a sub n equals your first term. 3.
That's really happening.
Plus our common difference. Our common difference is 5, and it's a positive 5. So plus 5, and then times n minus 1. And now I have the explicit formula that will allow me to find any number in that sequence.
I concur. Oh, snap! Ladybugs! What's up, ladies? Bugs, that is. All right, again, all we're doing with patterns is we're finding their numerical, the number that they are, the numerical value, and then we're just replacing with that so we can just do a sequence. So again, this is my first one, this is my second one, this is my third one, this is my fourth one, this is my fifth one. Looks like after this one, I'm going to be going to half a ladybug, or negative ladybugs. We'll find out. So here we got 4 times 4 is 16. I have 16 ladybugs. Here I have 8 ladybugs. Here I have 4 ladybugs. Here I have 2 ladybugs. Here I have 1 ladybug. Well, I can already tell you that doesn't look like it's going to be a constant value because 16 to 8 is getting smaller, and if I did that, I'd have to probably minus 8. But if I took 8 and minus 8, I'd be at 0, and I don't go to 0, so this is not going to be a common difference. It's going to have to be a ratio. And so again, with me, when it comes to ratios and it's getting smaller, I always think divide first because that's the way my brain works, and then I have to turn it back into a fraction. So I say, okay, 18 divided by what will make 8? I'm like, oh, it's divided by 2, because 16 divided by 2 is 8, and that divided by 2 would be 4, and 4 divided by 2, oops, that says plus, divided by 2 would be 2, and 2 divided by 2 would be 1. But I can't do divide by 2 because all ratios have to be fractions. So what's another way I can write divide by 2?
Multiply by
what?
1 over 2.
1 over 2, because that's the same thing. So again, my brain thinks divide, but I have to write multiply. So now I know my rate is going to be times 1/2, which is the same as divide by 2. And my first term is 16. And because I have a rate, this is going to be a geometric formula, and that is going to be a sub n equals a sub 1 times r to the n minus 1. And you can put that in parentheses if you could be putting it in the calculator. So to write this formula, I'm just replacing a sub 1, which is 16, with the rate, which is 1/2. Some students will write down 0.5. It's okay. You can, decimals and fractions are interchangeable with geometric formulas. All right, to the n minus 1. And let's see. Hey, look at that. We got it right. Woo! All right, I think that's it. Let's see. Boom, we're good. So, go try a couple problems. And if you're still struggling, we have a couple more harder ones down here.